In this lesson, we will graph transformations of y equals 1 divided by x and y equals 1 divided by x squared. So that is, we're going to apply what we know about graphing transformations to the basic rational functions. Now, we can graph rational functions that are not explicitly transformations of these functions. We would have to find the vertical asymptote, the horizontal asymptotes, their intercepts, and some other key points on the graph, but we could do that. So we're going to actually not cover that in this particular course. We will simply do the transformations of 1 over x and 1 over x squared. But when we do the transformations, we have to keep in mind that the vertical asymptote at x equals 0 and the horizontal asymptote at y equals 0 of these basic functions must be shifted through the transformations as well. Let's review the transformations that we've learned. If a, h, and k are positive real numbers and f is a function, then y equals f of x plus k will shift the graph of f up k units. Y equals f of x minus k will shift the graph of f down k units. Y equals f of the expression x minus h, so that's an inside change, will shift the graph of f right h units. Y equals f of the quantity x plus h, again an inside change, shifts the graph of f left h units. Y equals f of negative x reflects the graph of f across the y-axis. Y equals negative f of x reflects the graph of f across the x-axis. Y equals a times f of x vertically stretches f by a factor of a when a is greater than 1. And y equals a times f of x vertically shrinks the graph of f by a factor of a when a is between 0 and 1. So in this example, we want to identify the transformations of 1 over x and 1 over x squared, graph the functions using the transformations, and state the domain and range of each function, along with the equations of the vertical and horizontal asymptotes. So we have the function f of x equals 1 divided by the quantity x plus 3 plus 2. So the first thing that I would observe is that there is an inside change. When I say inside, there's something attached to the x at minus 3. And remember that when something's attached to x, that's going to shift it left or right. Because it's minus 3, it's going to shift it right 3. And this is going to shift 1 over x, so that is 1 over x, right 3. And then this plus 2 is on the outside of that function, and so that's going to move it up 2 units. Now we can set the denominator x minus 3 equal to 0 to get x equals 3, which is the equation of our vertical asymptote. We could also see that by just shifting that basic graph. Remember, the x equals 0 then is going to have to shift right 3 units and up 2, but a vertical line shifted up 2 doesn't affect it. So we're going to have this vertical asymptote through x equals 3. And I'm drawing that on this coordinate system that I have on the screen. And I'll label that x equals 3. And then our horizontal asymptote was originally at y equals 0. I'm going to shift it right 3, which doesn't change it, but then up 2 will take it to the point, or line rather, y equals 2. Now there is no reflection, so that means that the way the graph was going up or down is going to stay the same on the sides of these asymptotes. Now if you want to think about a key point, the point 1, 1 was on the original graph. So to shift it right 3 and up 2, so right 3, 1, 2, 3, and up 2, we'll take it to the point 4, 3. And the point negative 1 was on the original graph. So shifting it right 3, 1, 2, 3, and up 2 takes it to the point 2, 1. So we could do that if you wanted. Now if you wanted to find the intercepts, we could also go through that process. if I wanted to find the y-intercept, I'm going to find f of 0, which would be 1 divided by 0 minus 3 plus 2, which is negative 1/3 plus 2. 2 is really 6/3, so this would become 5/3. So at 0 5/3, there would be a point. And if I wanted to set the function equal to 0, 1 divided by x minus 3 plus 2 equals 0. If I multiply everything through by x minus 3, I get 1 plus 2 times x minus 3 is equal to 0. So I get 1 plus 2x minus 6 equals 0, which is 2x minus 5 equals 0, or 2x equals 5, or x equals 5 halves. So there is an x-intercept at 5 halves, 0. Now, I don't really have to do all that since I'm just using transformations, but I'm just trying to get a little bit more precise. And so we're going to have this piece that is approaching the line y equals 2 at the left end of our graph. And then it's going to be drawn through this y-intercept of 0 5/3, this key point of 2 1, the x-intercept of 5 halves 0, and then it's going to go down to negative infinity. And then on the other side of this vertical line x equals 3, we're going to go to up to positive infinity, and then we're going to come down through this point 4 3, and then approach the line y equals 2. So what is the domain and range of this graph or function? The domain is negative infinity to 3 union 3 to infinity. And the range from bottom up is everything but our horizontal asymptote, so negative infinity to 2 union 2 to infinity. Now I have the graphs that I'm going to put here, and sorry that it just put it on top of what I just wrote, so let me take that off for just a minute in case you need to see that. So the domain again was negative infinity to 3, union 3 to infinity, and the range is negative infinity to 2, union 2 to infinity. And I'm going to write that on top of my graph just so we'll be able to erase that. So now let's see the graph from the calculator. So I input 1 divided by, in parentheses, x minus 3, close parentheses, then plus 2 on my calculator, and I graphed it. And so we can see this exact graph that I have drawn by hand. There is this vertical asymptote, again, at x equals 3. And then we can see some key points on our graph. So we see this point 2 1, we see the point 5 3, we see the error message where we have this vertical asymptote. And so you can use that if you want to just confirm your work. But again, I want you to just think about what are the transformations and what would be this rough sketch of the graph. Now if you needed to think about end behavior, we would say that as x goes to positive infinity, so that is the right end of our graph, y is approaching this horizontal asymptote, which has the value 2. As x goes to negative infinity, so the left end of our graph, y is also approaching the horizontal asymptote, or 2. And then as we look at our vertical asymptote, as x goes to 3 from the right side, so on the right side of 3, the graph is going up, which means y goes to infinity. And then as x goes to 3 from the left, so on the left side of 3, the graph goes down to negative infinity. Now we have the function f of x equals negative 1 divided by the quantity x plus 1 squared. So this is a transformation of y is equal to 1 over x squared. What transformations will take place? Well, the inside change of plus 1 tells us that we will have a shift left 1 unit. And this negative on the outside tells us we're going to reflect across the x-axis. So when we think about how this impacts our vertical asymptote and horizontal asymptote, we had originally a vertical asymptote at x equals 0. So to shift that left 1 and then reflect it across the x-axis, we'll just keep it at x equals -1. And again, I can find that by setting the denominator equal to 0. If I set x plus 1 squared equal to 0, I get x plus 1 is equal to 0, so x is equal to -1. And again, we have an even multiplicity there, so I know that the graph is going to behave in the same way on each side of that vertical asymptote. Our horizontal asymptote, well, it was originally at y equals 0. If we shift that -1 and reflect it across the x-axis, it actually doesn't go anywhere. It stays at y is equal to 0. So let's think about some key points that were on the original graph. That point 1, 1 was on the original graph. And so if we shift 1, 1, left 1, it goes to 0, 1. But then when we reflect it across the x-axis, it goes to 0, -1. -1, 1 was on the graph of the original function, so we can shift it left 1 to -2, 1, but then reflect it across the x takes it to -2, -1. Now both of these branches went in the same direction. Originally they were both going up as we get closer and closer to the -1, but now reflecting across the x-axis will make them go down on either side of -1. And we're approaching the horizontal asymptote y equals 0 at our ends. So it's going to go close to this line y equals 0, but it's going to be below it. Then it's going to go through this point, -2, -1, and then continue going down as we approach this line x equals -1 from the left. And then on the other side, it's going to go down on the other side of -1, and it will go through 0, -1, and it approaches y equals 0 as we get closer and closer to infinity. And again, if I wanted to find the x and y intercepts, I could. Like f of 0 would be -1 divided by 0 plus 1 all squared, which is -1 over 1, or -1. So 0, -1 is our y-intercept. If we set this function equal to 0 to find the x-intercept, there actually will not be one. And we can see that because of the transformations that took place. So there's no x-intercept. Now what about the domain and range? So the domain is everything except for where it's undefined. So that is -infinity to -1 with the parentheses union, -1 to infinity. The range, well, the graph is below the x-axis, so it is from -infinity to 0 with a parentheses. And again, I have the graph on here from the calculator. So on the calculator, I input -1 divided by, in parentheses, x plus 1 squared, and then I graphed it. So we can see exactly the same shape that we just did by hand. I also put the table here if you need to get some confirmation about the points that you found. But we can see that this -2, -1, we can see the error message where it's undefined, and this point 0, -1 are on our graph. Now if you needed end behavior, we could say that as x goes to infinity, y is approaching 0. As x goes to -infinity, y is approaching 0 also, right? So that's what's happening at the left and right end of our graph. As x goes to -1 from the left, so on the left side of our vertical asymptote, the graph goes down. So we say y goes to -infinity. And as x goes to -1 from the right, So the right side of our vertical asymptote, the graph is also going down to negative infinity.